Good morning, everyone. I hope you're having a good time, you're having a good day. Thank you for having me. It's my second conference in Netherlands. Last year I was at Amsterdam JS, and now I'm in Utrecht, which is absolutely fantastic. I love it. It's such a nice city. And today we're going to speak about progressive web apps. And actually, the reason why I started looking into progressive web apps is a very selfish one. As a developer advocate, many people would think that we party a lot, and we do. We actually do. Sarah, can you please confirm that?
Yes.
Yes, perfect. She said yes. Also, some other people might think that we burn through their money, and we definitely think that we're super in control, we control the world, we have everything, we got this. But actually what we end up doing is this. We end up sleeping in a plane a lot of times. And not only there, we also sleep in trains on our way to the airplane, we sleep in hotels, and what all of these places have in common is really bad internet connectivity. So that's terrible. And this is what made me think that I wish that every website out there would actually be a progressive web app. It would be so useful. Many times before a conference like this, I'm kind of working on my demos, making a last change, a very small change, or working on my slides. And every single time it's like, why is this happening to me? Like, I need to do this, I want to do this. And I really want internet to work for me, but it doesn't. So my name is Simona Cotin, and as Sally mentioned, I work as a cloud developer advocate for Microsoft, where basically my role is to make sure that JavaScript is a first-class citizen in the cloud. So if you have any complaints or any good things to mention about JavaScript in the cloud, do make sure to reach out. I'm happy to listen to you. And then if you have any questions, you can find me on Twitter at Simona_Cotin. I'm really happy to chat about everything. I also want to introduce you to this awesome artwork. It's been designed by Ashley McNamara, and this is Bit. This is our friend, our team's friend. And it's a raccoon. And the story, the reason behind Bit being a raccoon is that raccoons go everywhere. And that's what our team does as well. We go everywhere where developers are. Cool. So today we're going to look into progressive web apps, as I mentioned, and we're going to look at an intro to progressive web apps. So for those of you that are already familiar with the concepts, this is going to be a good refresher. We're also going to dive into the main concepts. And understand why Angular is such a good match for progressive web apps. Kind of answer the question, PWAs versus native. I'm sure that many of you are asking this question, like, can we do PWAs and just not work on native applications? Well, we're going to see what's the state of that. We're also going to look into some of the gotchas and how maybe we can find some fixes. And finally, what tools can we use that can make us more productive in what we're doing. Okay, so let's start with what is a progressive web app. Well, progressive web applications are basically just web applications that behave like a web app, but also appear to the user like traditional applications, like native applications. Another definition that I absolutely love is that they're just websites that took all the right vitamins. And this definition comes from Alex Russell's website. For those of you who are not following Alex Russell, you should definitely start doing that. He's done tons of work for web performance and for progressive web apps. And he writes beautifully. Like, if you want to read good quality web performance articles, go make sure check out his blog post. Another thing that Alex did was, together with his wife, Frances, they coined the term progressive web apps. So they were just out for dinner, and like every couple of software engineers, they were talking about the state of the web, and they were talking about what would make a great web experience or a great experience on the web. And they came up with this list of things that would make a great experience. And the first one is, whenever we're building web applications that's intended to be used on a phone, this application should be progressive. And what we mean by progressive is basically based on the type of browser that you're using and on the type of experience that the browser is offering or is supporting, the user's experience should enhance. So if you're using a very old browser, the website should still work. It should have its basic functionality. But as you're moving to a better browser or a higher version or latest version, the experience should improve. So say, for example, the newer browser supports offline, then definitely your website should offer that kind of experience to your user. Another important thing is that our websites are responsive. Because the idea is to use PWAs on a mobile, then definitely your website should look good on a mobile, just as well as on a desktop or on a tablet. So make your applications responsive if you want to have a good progressive web app. My favorite, make your applications connectivity independent. One of the key things about native applications is that you can open a native application on your phone while you don't have internet, and you can still view some data, you can still view an application that looks like something, and have the history of your browsing. You can still do stuff. So that's one of the key things that makes native apps so powerful. If we want to offer the same experience, we should make sure that progressive web apps are connectivity independent and they still give you a good experience when you're offline. They should be app-like, so the navigation on your application should feel like a native application. They should be fresh. So imagine you've been offline for 2 days because you were in the mountains and you had a lot of fun. But then when you come back online, you should definitely have the latest data available. So for 2 days, you're going to see your friend's Facebook activity from 2 days ago. But then now you should have the latest data. Because as we're going to see later on, service workers are super powerful. We have to make sure that our application is safe. So the content that we deliver to our users cannot be tampered with. So that's key. And then one of the wonderful things about the web is that we can search. We can find every resource that's out there by using a search engine, and that makes our applications discoverable. One of the not so positive things about native applications is that you can only deliver them to your users through an app store, which makes it hard to find them. So then with the web, people can just Google or search, and they would find your content. Re-engageable, how many of you love push notifications? How many of you have notifications enabled for at least one app on your phone? At least one app, right? For me, it's Twitter. I'm not sure for the rest of you, but definitely push notifications are something that take us back to an app, or it's actually something that keep us connected to something that we want to stay connected. So we want to have the same experience on the web as well. We want to be able to reconnect with an application. Installable, whenever we're using the same application multiple times, maybe we want to actually, instead of going to a browser every single time, we want to access that application from the home screen itself. So we want our web application to be installable on the home screen of the phone, so it's easier to reach and easier to open. Another cool property and great property of the web is that every resource out there is linkable. So I can share URLs with all my friends, and that's perfectly fine. They can see what I'm seeing right now. With native applications, it's not easy to do that. Most of the times we just take screenshots and then we tell our friends, oh, if you want to see this, go navigate to this, take these steps and you'll see this screen. Cool. So that's a lot of words that might have meaning, might not have meaning, but what we're really interested in is how do we actually make this happen in practice? What's the code that we need to write, and what are the concepts that we need to get a hold on? So we're going to start with this thing called the baseline appiness, which defines what makes a base progressive web apps. What are the key things that we need to have in our application so that we can say this is definitely a progressive web app? The first thing that we need is implement service workers. The second thing is a web manifest. And all of this, as I mentioned earlier, has to be safe, so it has to be delivered under HTTPS. So service workers, web manifest, and deliver our content over HTTPS. This is what makes a base progressive web app, base appiness. So then let's dive into those concepts. Like, what are service workers? Well, service workers are basically just some proxies that sit between our web page and the network. And based on the strategies that we've defined and the status of the network, we can deliver content either from the cache or from a backend over the network. Another definition that I love is that we can think of service workers, or we can think of web requests as planes that are taking off, and we can think of our service workers as the air traffic controller. You can decide, the air traffic controller decides whether the planes take off or not, or what's the direction, and just like that, the service workers are basically deciding whether the content will be retrieved from over the network or from the cache itself. And this is a paragraph from this book that I highly recommend if you want to go into more detail about progressive web apps. It's written by Dean Allen Hume, and you can find it on Amazon, and not only that, it's Building Progressive Web Apps. Okay, cool. Well, the next question, probably most of you know already that recently, the support for service worker has been implemented in Edge and also in Safari. So if you're wondering whether service workers are available and are supported in all the latest browsers, the answer is yes. Jake Archibald has built this website that has been around for quite a while, where he would list all the browsers that are supporting service workers, and for a very long time, the only ones were either Chrome and Firefox, but now everything's like all the browsers are supporting service workers, which is great. He also writes a lot of content about the web and about web performance, so I recommend you check out his blog posts as well. Cool. But if we want to understand better how service workers work, in terms of like an actors type of diagram, we have the web page, and then the dotted line is the network. So then the service worker, as I mentioned, sits on the same side as the web page. And then we have a backend where we retrieve data from. And finally, we have a cache that we can retrieve data from as well, and that sits on the same side as the service worker and as our web page. And the service worker is super powerful. It's almost like a mini web server that we have in the browser. So it can intercept requests, and it can decide, based on what rules we've defined, it can decide what kind of content to return to our user. So a user goes to a web page, and it triggers a request, and then the service worker will catch that event, and it works really hard, and it decides whether this content should be retrieved from over the network or from the cache. And these are strategies that we define ourselves as developers. So based on, for example, if we want to improve performance, we might, even though we have internet connection, we might actually decide that we want to deliver content from the cache itself, because there's different types of content that our users are seeing, right? There's the first 3 seconds that are very important on the web. Does anyone here know what 3 seconds is on the web? Yeah? I see someone there.
No, the concept is that 3 seconds, you lose people.
Yeah. So as our friend there mentioned, after 3 seconds on the web, if your user doesn't see anything on your page, they will just leave that web page. But it's not only that. My colleague Sarah Drasner, who's also amazing, she has a talk where she mentions that if the user doesn't see anything after 3 seconds, there have been studies that have figured out that our brain perceives those 4 seconds as a horror movie. So the brain's reaction to waiting for our page to load is the same as when we're watching horror movies. So we have to be very fast, at least for the first part of our content. And that's why we might decide that we want to deliver data immediately from the cache, and only after that go to the network. Okay, so as I mentioned, the service worker does a lot of work, and it decides to go to retrieve data from the backend, and then it processes that response and it sends it back to the web page. In the other scenario, we just go to the cache and we return that data from the cache and return it to our web page. So this is the 2 major scenarios where we would, how the service worker interacts with the web page and with the backend. 2 things are important with the service worker. The first one is the scope, and the scope defines what requests and what's the domain that the service worker controls. So what request the service worker controls. And then the second one is lifecycle, which we can tap into. So we can listen to events from the lifecycle of a service worker. And the default scope for a service worker is the current one that the service worker is defined into. So this means that all the requests that goes to that path will be intercepted by the service worker. And then the life cycle starts with no service worker, and then once we register that, we go into the installing phase. So the service worker enters this event called installing, and this can be successful, and that means that our service worker moves into the activated status. Or, for example, if something has happened during that install moment where we're trying to cache some data. So when you're installing the service worker, that's when you're going to cache the critical data that you need for your website. And if there's any issue when downloading that data, that means that our service worker is going to enter the error state. And from that state, it's basically next time that the user tries to access the page, it's going to try installing again. And then it can either go into idle state or from that go to terminated state, which means that our service worker is still listening for events, but it's not active anymore. It's not using memory and all of that. And then it also listens, it can listen to fetch events. Okay, so how do we register a service worker? Well, in our JavaScript, we just check whether the current browser supports service workers, and if that's true, we register a file that's like a service worker that's defined in the serviceworker.js file. And then this is how we actually go ahead and listen to events. So the lifecycle events that I mentioned earlier, on the first line there, you can see that we're listening to the install event. And then there we can wait for assets to be cached. And in this case, we're going to cache a cat.svg file, and we're going to save it in the caches object, which is available in our browser. And then that's where maybe if there's an error, we're going to cancel the installation of the service worker. And then we can listen on line 9, we can listen to the activate event. There's not much we want to do there. We're just going to console log something. And finally, we're going to intercept the fetch method. And whenever someone is looking for a dog.svg file, makes a request for a dog picture, what we're going to do is we're going to respond with a cat picture because we want everyone to be cat people. Right? Yeah? Woohoo! Okay, cool. And then how do we test service workers? How do we know that all the code that we've written is actually working? Chrome has amazing support for testing this. So we can go to the application tab, and there's different things we can see there. So the first thing that you can see is the manifest, which we're going to talk about later, or in a second. And then you can see there's service worker. And there's different options here. We can update our forcefully update our service worker. We can see the status of the service workers. When was the last time that it was updated? We can test things like push. So this is very powerful. If your service worker doesn't show up, this would be the first place that you would go to test whether it has been installed or not. The next thing that we can do is do things like, what happens if I'm offline? Let's see what's the behavior if I'm offline. We can also debug our service worker just like we would debug JavaScript files. So we just go in the service worker file, add breakpoints, and we're going to stop there. We can inspect variables and understand what's happening. And then if we actually want to unregister a service worker, say you discovered a bug and you want people to still see the new content for your website, then you can unregister service workers by just calling unregister on the registration object. Cool. So by looking at service workers, we achieved connectivity independence, which is awesome. We can also make our websites fresh, which means that if we're back online, we can retrieve data. And then discoverable already because we're doing the web, that's happening. So we're super cool. Awesome. The next thing that we need to look into is web manifest. And what a web manifest does, it tells our browser that this is an application that you can install. And it also describes how we're going to install this application. It describes things like what kind of icon we're going to use on the home screen when that app is going to be installed. Or what's the name of the application when the user that's going to be used when on the home screen. Normally, it's a JSON file where you can define things like, as I mentioned, short name, that's the name of the application, icons, the ones that we're going to use, and there's different sizes that we need to support based on different devices. And then the start URL is really cool as well because it allows us to understand how many people, to track how the users are accessing our application. So in this case, by just adding UTM source home screen, you can actually figure out if maybe 60% of your users are accessing your app, your website from the mobile, and maybe optimize for that. Or if it's only 20%, probably you need to do more work to make your experience better because probably they're not having a great time using your mobile app. And then we can also define things like how is our application going to be displayed when it's opened from the mobile with things like display. And standalone means that our app will run in its own window. So you're not going to see the browser, URL, and any of that. OK, cool. So our app is also installable. We've added installable here. The final thing is that our application, our website needs to be safe. So we have to deliver everything over HTTPS. Fantastic. What about Angular? How can we build progressive web apps using Angular? You're going to be surprised to find out that it's actually very simple. So by using the Angular CLI, we can generate a new app, or we can use an existing app that has been generated in the past with the Angular CLI, and then we can add the Angular PWA package to our project, and that's going to install the service worker, and it's going to make it available for us. So it's only one command line that will add the basic things that we need to generate a progressive web app. And these are the files that are being either modified or generated for us. So you can see a list of icons that have been generated, and then the Angular JSON, which is the configuration file for the Angular CLI, has been modified. So if you look in detail in Angular JSON, one of the things that happens here, we're adding the service worker flag. We're setting it to true, which means that at build time, the Angular CLI will make sure to copy the service worker file from an NPM package to our final bundle. And then another thing that we're adding in angular.json file, we're adding a link to our manifest.json file. So we're making sure that's going to be included in our final bundle. And then in the app module, which is the first file in an Angular application, that's where our application starts from, and we're going to register a service worker by importing, so we're importing the service worker module, and then we're registering this ngsw worker.js file, which has been copied earlier at build time. And we're only enabling service workers for production. Who here knows why we're doing that only for production? Sarah knows.
Because service workers need HTTPS, and also because it's a pain in development to be always hard reloading your web page.
Yeah, so Sarah mentioned that the first thing we need to always have HTTPS, and then it's a pain in development mode to hard refresh the application so that our page doesn't use cached data, because that's what our service worker is doing. It's caching, it's using cached data. So we want to make sure that in development mode we have the latest data. That's really important. Okay, and this is a file that's going to be used at runtime, and this is how we define in Angular what kind of data is going to be refreshed, it's going to be cached, and what's the strategy for that. So you can see that we have asset groups, and the first element there it has the name app, and it defines the resources that are going to be cached at install time. And in this case, it's going to be the index.html file, all the CSS, and all the JavaScript files. And these are our critical resources that we always want to show and we always want to cache for our users. And in the second part, you're going to see that we're only caching the assets folder, but we're doing that lazily because we don't want to spend precious time when our application is just opening. We don't want to spend precious time caching those items and downloading them from the internet. We want to load them lazy. And this is really cool. So we use a JSON file to describe the resources that are going to be cached. And the actual service worker itself is going to be, it's written by Angular. So it's abstracted away for us. OK, and then we mentioned that we need to build for production. And these are the files that are going to be generated for our application. And the key ones for service workers and for PWAs are the NGSW worker.js and the JSON file. And then we can go ahead and test whether our Angular application is actually PWA. And we can do that using Chrome and using this thing called Lighthouse. And Lighthouse allows us to test whether, uses a sort of checklist to check whether an app is progressive web app. And we mentioned already that there's 3 things that are important for a progressive web app. Service workers, right? So Lighthouse is going to check whether there's a service worker registered for our application. Web manifest, Lighthouse is going to check whether our application has a web manifest. And then HTTPS is going to check whether our app is served over HTTPS. As you can see, with a bare-bone application generated by Angular CLI, we are only 82 progressive from 100. Can anyone guess why? HTTPS, perfect. OK, we're going to see it. So yeah, what's happening? Well, the first error that we have there is that I didn't define anything that the user can see when there's no JavaScript enabled. And because the goal of progressive web apps is to always give feedback to our users, we have to have some form of telling them you have to enable JavaScript to use our website. So I just added this NoScript tag where I'm saying that it's 2019 or 18. What year are we in? You need JavaScript enabled. Nothing's going to work without JavaScript. And then the next thing, as our friend here discovered, is that we need HTTPS. And this was, I knew how to solve this. I can just go to Azure, deploy my website, and just turn HTTPS only with this button. And that was it. That was fast. And now we have 100% progressive web app. And this was easy. And it's just a checklist. Obviously, when we're building progressive web apps, we have to make sure that we're caching the right data, and we have to make sure that performance is great as well. That's a key part of building progressive web apps. So we have to make sure that we're keeping track of that every time. PWAs versus native. Everyone's asking that, right? Let's have a look at the state of the web first. We have some of the 3 major browsers, and you can see that in Chrome, using this feature detector, which has been built by Tomek, I believe that's his name, we can see that Chrome supports almost all features that would make a good progressive web app, except for getting installed a related app. And that's like, if you have a progressive web app and you already have a native app installed, the browser maybe should be able to tell you that. But then you can see that in Firefox, only offline capabilities and push notifications are enabled, but also we can add to home screen from Firefox. And then on the phone, on Firefox, we only have offline capabilities and support for payment requests. So those are the only APIs that are being implemented for Safari. Some of these APIs are really important for PWAs, but we can have a look in more detail, kind of what kind of hardware support based on use cases. Like if we were to use, to build an application like Maps, or something that would be very important to know what's the location of our user, then geolocation is actually supported in all the major browsers in the latest version. So that's great. We have support for that. We can do that. What about camera and microphone? Most of the times, like if we're building an app like Snapchat, we definitely need to use the camera, and we can do that in most of the browsers. So if you were to build an app that does that, we're cool. We can do that. What about Bluetooth? Well, there's, only Chrome and Safari and Samsung Internet. Did everyone know that that was the icon for Samsung Internet? Yeah, so they're doing a lot of work to push the web forward. So if you have Samsung phones, maybe you can try that browser as well. And then what about some more funky kind of API or support, like NFC? It's only supported in Firefox. Ambient light sensor, this will kind of tell us, will dim the luminosity based on the light outside. It's only supported in Edge and Firefox. And proximity, kind of when you're calling someone from an application, they will figure out whether your phone is close to your ear or if it's not, and based on that, reduce volume. So that's only supported in Firefox. If you wanted to build that kind of capability into our application, it would be supported only on Firefox. What about from a software perspective? Push notifications, save to home screen, full screen, offline, clipboard, which are all key features for building full progressive web apps. They're supported in most of the current browsers, except for Safari. So we don't have support for push notification. There's no obvious way to save to home screen from Safari. You cannot just add the pop-up that you can add in all the other browsers. And there's no support for full screen. There's workarounds, but it's not supported out of the box. And offline and offline and clipboard, they're supported in Safari as well. Currently not supported, and there's no plans for that. Contacts and calendar, alarms, calls, SMS, listening to voicemails. And probably that's a good thing, right? Because we don't want websites to be able to access our calls history or our SMS, be able to send SMS from our phone. I feel that it depends on how you're feeling, like in terms of privacy, but so far I'm comfortable with that not being supported on the web. We can also install applications from the App Store. One of the things that it's not great with native applications, the fact that applications have to be installed from the App Store. But then if you think of users that are not power users, they're not in tech like us and know how to do things on the web, like my mom or my dad, they might not know that they can click on a button and actually have their app installed. And like even home screen, the home screen word, what does that even mean? How would they know that home screen is the screen of their application? So add to home screen, what's that? I have no idea. I'm going to click no because I don't know what that is. Whereas they know that if they go to the App Store, they're going to be able to install applications. So that might be, it's nice that we can install PWAs from the App Store as well. And they're available on Windows and on Chrome OS. What about push notifications? I I have a very short demo here for anyone that wants to follow along. I have built this application, which in the beginning was meant to look so much nicer, but I ended up not making it look very nice. And I added the push notification functionality. And how push notification works, and I'm actually going to, if you want to try it yourself, if you want to subscribe to notifications from my app, you're going to have to go to this URL. Let's see. No, it doesn't. So it's simona-cotin-pwa.azurewebsites.net. So here, in order to implement push notifications, there's two things that we need to consider. So first, there's a push API, and that's what our web server is doing. It's pushing notifications, and then there's a notification support, and that's what our browsers are supported. So there's two actors there. And everything is being intercepted by, for example, in the case of Chrome, it's Firebase Cloud Messaging. Messages are never sent by the web server to a browser. They're actually being sent from a browser push service to our user's browser. And that happens because push notifications can be really, really, really annoying if they're used very badly. So there has to be a third party that will make sure that we're not pushing users away. And the way we can implement push notifications in Angular, there's a service called SWA Push, and we can subscribe to notifications using that. And then I implemented a function where I'm just using this library called Web Push, and I can push changes there. Sorry. So if you got to this website.
Are you sure the URL is correct?
So, does it not work? It's SICOTIN-PWA.azurewebsites.net. And if you go to the notification tab, you can click subscribe there. And normally you should get a screen that asks you whether you allow notifications or not. In Chrome here, I can just go on the secure, I can click on secure there, and it will ask me if notifications are allowed or they're blocked. So you can see here the options. And then, let's hope this works. As I mentioned, I have a function that will send notifications to everyone that has subscribed. So I can just click send here. And this is like a HTTP endpoint. What is happening? Well, here's my notification. Can everyone see it? Did you receive it as well? Yeah? Did it say that you're awesome? Okay, so I'm going to show you how this looks like. So as I mentioned, we first generate the subscription, and we have to save that somewhere. So we have to save it in a database. So here you can see one entry of the subscription that has been created for your browser. And one of the key things that we need here is the endpoint, so that the server knows where to send a notification back. So that's the HTTPS, FCM, Google APIs. That's the Firebase messaging server. And that's who's going to send the notification to your browser. And then we also have, because it's important to create a relay, to make sure that the browser and the server are authenticated, are the same resource, we are using a key, a private key and a public key. The private key is only stored on the server that sends the notification. And I can show this here. So this is where I'm actually sending the notification. I'm using the web push library, and I have these vapid keys. I think it's voluntary application. identification, something like that. And we have a public key and the private key. We create a notification payload with things like what's the title, what's the body, what's the icon. So we can define the icon for our push notification. And then we can read all the subscription from the database and send that subscription. And that subscription is going to be intercepted by the browser, first the Firebase service, and that's going to send the notification to our browser. And in Angular, let me see, notification service, where are you? Wait. So this is how we're saving the notification. We're just posting something to a server. Yeah. Okay. Cool. What are the gotchas? App install banner. App install banner is the notification that we get where we ask users whether they want to save this application to their home screen. And unfortunately, this works differently in different browsers. So if we look at Mozilla, we're going to get this notification that will tell us that we can easily add this website from that icon that looks like a home with a cross. On Chrome, we actually get a notification at the bottom of the screen that allows us to add to home screen directly from here. And then on Safari, that doesn't happen. We have to manually go into the website, into the browser's menu items and select it ourselves. What about the home screen icon? In Chrome and Firefox, the icon looks exactly as we defined it, whereas on iOS, it's actually a screenshot of the app when we're saving the application to home screen.
It worked for yours?
It worked for mine, but it didn't, the notification, you mean?
The notification, it doesn't work, but the icon works now. So.
But that's because I added a fix to that. So there's a gotcha, and there's a fix for it. First, it's only a screenshot, but then you can actually add the Apple Touch icon and link tag, and you can define icons that can be used on your application. So now I have a better icon for my app, but I have to do that manually, so it doesn't work as we expect it to work. Another thing that's interesting is storage. So how much data can we store in our browser? Well, depending on the browser, we have different thresholds. So for Chrome, it's always going to be less than 6% of free screen, free memory, whereas for Safari, it's going to evict our cache if it's more than 50 megabytes. And another interesting thing is that after a couple of weeks of the user not using our website, it's actually going to unregister our service worker as well. It's going to delete everything. So what we thought was a progressive web app that's going to always give our user, no matter when they're using our app, it's going to give the same experience. On Safari, that's not going to work. They're just going to have to download everything again. Packaging. In Chrome, apps or progressive web apps are listed as apps. And you can manage them from the apps, and you can see how much storage our progressive web app is using. You can see how much data our progressive web app is using. Whereas with the iOS, everything is stored under Safari, so you cannot actually see how much storage your app is using. And yeah, probably that's going to evolve. I finished my time. Okay, tools. We've seen Lighthouse. PWA Builder helps you generate a manifest.json and service workers. You just have to enter a URL, and then you can actually download the code for that. Workbox is another collection of libraries that will help you build offline capabilities in analytics. If you want to test, Pinterest has worked on a set of libraries that will help you test your service workers. On Hacker News PWA, that's a collection of of apps that have been implemented using different frameworks, and you can see even the Lighthouse score and a lot of data there. I highly recommend you check this out. The Angular CLI, Vue, and React have a similar capabilities, so you can use those as well. The thought that I want to leave you with is that progressive web apps are a new way to deliver amazing user experiences on the web. So whenever you're thinking of building your application, make sure to keep in mind your user's experience. Thank you very much.
So you actually answered lots of the questions I had on here right at the end, so that was great. So I can skip a bunch of those. So we've had a few questions about app stores. One of them is the Google Play Store offers something called Instant Apps, which I only just learned about as well, that you don't have to install. Are they PWAs also?
I know very little about Instant Apps, but I think they're not PWAs.
Okay. I'm going to Google that afterwards. Do you think that having an app store is a positive point? Like, how do you see people being able to discover these apps? Because if I'm looking for something, I know that there's one central place to go that I can find. So how do you see PWAs being able to be as discoverable, if at all?
I think it really depends on the type of user. So I would feel much more comfortable using the web as opposed to using the app store. One of the things that I'm really a lazy user, so I don't update my apps unless I have like 50 updates available. I don't like going to search for things in the app store. I much rather prefer using the web. As I mentioned earlier, users that are not power user and they've just learned how to install apps, they're probably gonna prefer going to the App Store. And that's why I think it's great to have both options. So being able to install apps either from the App Store or from a pop-up that we have in the browser, that's really great. It kind of addresses both audiences, where you have users that are familiar with how to use the web, and how to use native apps.
Cool. All right, so last question is, if you're doing local development, your PWA might not be on HTTPS, so how can you develop them and debug locally when they're not?
So you can run
with service workers specifically there.
With service workers. Yeah. I think there's a flag where you can say that let's run this without HTTPS, and that's gonna work.
Great, that was easy. Okay, so please give it up again for Simona. Thank you.
Thank you.